Hey everyone, how are we doing? If you're in the chat, feel free to say hi. Let's go ahead and reset Mubot. Do we have 17 people watching? No way. Mubot must be lagging behind 17 people? We might. Mubot can't be serious. 17. If you're in the chat, say hi. Let's see. No one said hi yet, so maybe I don't know. What are we doing today? What are we practicing? 201, 320, 474, 475? You name it. Shira, great to see you here. Mubot says he's offline. He says he's connected. Can you do 13 homework vitamin D? Of course. 100 points for asking. Thank you. It says stream offline. Well, it's not possible. You're here, Mubot. You're awake. He's not doing points. Mubot, wake up. We'll do the question here in a second. Mubot says hi. There we go. Can you do points now, Mubot? Can you? You good? We'll see what he does. He's being weird. Well. We're going to reset Mubot one time. Then we're going to go do homework here while Mubot is waking back up. He's going to wake back up and see if he can stream for us. Let's get the homework going. Vitamin D question. Okay. Going to take a look right here. Chapter 13. He says he's still offline. Well, this is not good if Mubot's going to be weird today. He was in the last class, so I have no idea. Maybe need to reset the computer between classes. I have no clue. He is being odd. He does that some days. But how are you doing today? What are the chances the illustrious Great to see you here, Matt Carter. I've been emailed by a few students saying that it's full. So glad to hear there's so much interest. I do not have the ability to add students, but keep looking for a spot. Thank you, Matt. Appreciate the compliments right there as I try to wake up Mubot. He is sleepy. I think I'm sleepy. Mubot's sleepy. He just doesn't want to wake up. We're looking up this vitamin D question. I don't have any control over adding students, but keep looking for... Oh, Mubot's awake. Take me with you. It still says stream offline, but Mubot's doing points, so we're good with that. It'll work. So let's go check out the intervals. But Matt, I will be streaming live. I will be offering help. So even if you're not in my section, I'll be here to offer help. So just swing on by. And yeah, chapter 13, vitamin D. Hey, good to see you here, Kaya. We're about to do the vitamin D question. Let's go check it out. Okay, so the vitamin D question, we were doing some tools and techniques in class, is going to be a confidence interval question. So in this question with confidence intervals, what is going to be the main thing for us to do for any sort of confidence interval question? All confidence interval questions are all questions like this. The very first thing we do is what? And now Leo might not be here today, but what would Leo tell us? If we had a question like this, and we're saying the first thing we do, what is the first thing we do? What is the very first thing we do for a question like this? Of the very first thing we do is we start doing what? So we get a question like this, vitamin D is being taken, yada, yada, yada. A recent study of 3,100 children found 20% of them, not 20 of them, but 20% of them are deficient in vitamin D. So what do we start doing for this question? What do we start immediately doing for this question? We get a question like this and we say, okay, I'm going to start doing what? So I need help with this. I need you to tell me what direction to go while working this question. It's like my first line of attack for this is to immediately start doing notation. Great job right there. There we go. Do you know any of these values? Do you know any of these values right here? What are any of these values? So what are those values right there? What are those values? Surely we've got some of them. And so if you're doing this, it says to make a confidence interval, your confidence interval will be the format of p hat plus or minus z star, p hat, q hat over n square root. So we know n, and this is p hat. If p hat is equal to 0.20, q hat is equal to 0.80. And so p hat is 0.20, q hat is 0.80. And so p hat times q hat over n square root, we can solve that. But now what is the z? What is z and what's the point of z? What does z tell us? If you're in the morning class, you know it, but if you're not, that's all right. I don't know is a fine answer, but what does z tell us? What's the point of the z in the confidence interval? As we are building a confidence interval, we'll go back to the notes from this morning. We'll be doing this in today's class. The z in the confidence interval will be used to do the what of the confidence interval. We're going to the notes where it's at. The z in the confidence interval, which I was just drawing right here, the z in the confidence interval will be used for the what. What is the z directly related to? And it's on the slide to help out with it. So we have p hat plus or minus z times p hat q hat over n square root. The z is going to be directly telling us, and look at the slides up there, the hints on the answer screen. The z will be telling us our what level for the interval, how blank we are in the interval. The z will be telling us, it's called the critical value, and it's how confident we are. So great job right there, Shira. It is the critical value of how confident we are. So we need to find out how confident we are to figure this out. Well, let's go look at the question itself and see how confident. It says we are 98% confident. So this is what the z is going to be associated with for this interval. And we need to go over here to the David M. Lane applet to solve this now. So the David M. Lane applet is going to allow us to find the critical value for a 98% confidence interval. So we go over here and we put in 98% confidence, and the z-score needs to be the between, and we've covered 98% of the curve. 2.326 is the z-score, and I'm getting that from either one of these. Plus or minus is going to be the right answer because we're going to do plus or minus when we make our interval. So that is the z-score for 98% confidence. And let's bring it back over here. We now know our z-score is 2.326. There we go, right there. So now we're going to plug in our numbers, and this will be our solve. P hat is 20% plus or minus the z-score of 2.326 square root 0.2, 0.8 over 3,100. And there it is right there. So with this, let's go take 0.2 times 0.8. And we're just going to solve. That is the standard error right there. So we've just solved this equation inside of here for the standard error. That's just a mathematical solve of that. Then we're going to times this. It's already been square rooted by 2.326. And now we've just found the what, Shira? We've just found the what. I'm showing it here visually. This is now the what of the interval. So that value right there is the what of the interval. So think it's everything after the plus or minus. We would say that is the what of the interval now. So mathematically, I've solved everything on that equation, and we've found the what of the interval. What have we found of the interval? We found the what of the interval right here. So you'd say this right here, not kind of, not the confidence, but the margin of error. Everything after the plus or minus will be the margin of error of the interval. So 0.20, yeah, catalog sales, you bet, Cassandra. This is everything after the plus or minus is the margin of error. So now we just need to add and subtract this to the interval. So we're just going to rewrite the interval as the center plus or minus the margin of error. And the margin of error is 0.0167. And so we're just going to add and subtract it. And to get a lower bound, we'll just do it. There we go. And now we'll do the upper bound. And there we go. Is this making sense? I'm going to bring my chair back over here. Squeaky chair. Okay. Does this make sense right here? Is this all Sarah's first? Yeah, ask BAS questions right away, Davis. Thank you, Davis, for being here. 100 points, of course. We take all questions that we can take, and we just keep working away on them. So keep asking, Davis. Drop those questions in the chat. We got Cassandra's question next, and then Davis, drop a question about BAS. Let's do it. Good questions, Davis. So we haven't asked you yet, but BS questions are awesome. And so here's the upper bound. It says to 3 decimals. So we'll go ahead and round that down. Awesome. Oh, really? I cannot use this calculator. 0.20 minus. Oh, 0.20. Somehow I have the minus of that in there. There we go. I think I've copy pasted everything correctly. Double check your copy paste. 3 decimals, we're good to go. And I think that does it. Check answer. We did it. So make sure. Oh, there's more. What does this interval mean? I am 98% confident that the true proportion of children with vitamin D deficiency is contained in the interval blank to blank. So we are 98% confident that the proportion of vitamin D... No. That the proportion of children with vitamin D deficiency is contained in the conf interval. And I do want to stress that what this is having you do right here is the interpretation we ended the morning class with. We'll do it in the afternoon class, where we say, I am blank percent confident. Ooh, INMT over the summer. Yeah, let me talk about that here in a moment, Kai. We'll do that between screens. Kai, good questions. So I am blank percent confident that the true blank is contained in the interval blank to blank. That's what you're seeing in this question right here. So practice writing this down. These are interpretations on the third test. I usually say I am 98% confident the true proportion of children with vitamin D deficiency is contained in the interval lower to upper. And then you have a theory question here, which mimics the notes also, because it's that 98% of 98. If you change this to 98, it'd be 98% of 98% confidence intervals are expected to contain the true parameter of interest. So about 98% of random samples will produce confidence intervals that contain the true proportion. So we would say, 98% of 98% confidence intervals are expected to contain the truth. And that's to mean if we do repeated confidence intervals, like repeated samples, and make 98% confidence intervals, 98% of them are expected to contain the truth. So that's a theory question on what does this 98% confident really mean? And it relates to the repeated making of intervals. 98%, if it's 98% confident, 98% of 98% confidence intervals are expected to contain the truth. It's not about one confidence interval containing the truth. It's about the repeated process. And Davis, feel free to drop a BAS question. We'd love to do some right here. Let's head back over to the main screen. Wrong button. Kai says, I am wanting to take INMT, the information management, right? That's a good class. Over the summer. Do you have any recommendations for the class? I also wanted to take BS20, but only one class is offered and the time doesn't work for me. Darn about the time. That's a bummer. INMT, I've heard, is amazing, and it's tough, which is good. That's good combo right there. Like, you're going to learn a lot. I believe you use SQL, so definitely. Hey, Leo, what's up? Good break, Leo. Good break. We were asking about notation earlier, Leo, so we didn't have you here to answer notation, brother. But if anyone else is taking INMT, also, hopefully we can get people together on the Discord, kind of, keep the channels going strong. Yeah, but you're going to learn a lot. I'm taking IMT. Leo, advice for Kaya right there, and, help each other out. The question asked about the difference between the average birth weights of babies born to mothers who are graduated high school and those who haven't, a minimal predicting birth weights from mother education. And I had to correct something in my section. So we'll take a look at that, Davis. You got it. Let me take birth weights, mother education. And you're doing the quiz, right? I might need to send an email out to instructors. Davis, I bet you're doing it right. There might be an issue with the quiz. So let's see here. We got catalogs, and then Davis, yours is next. And we'll show you how to make that indicator variable model. Davis, thank you so much. It's not too bad, however. I am PC nerd, and I know a lot about Office apps. Nice job right there, Leo. Well, Leo, especially on the Discord, if you want to offer students advice I'm never going to make a channel for a class I don't teach, but you're always free to meet up with students and ask students. Like, I'm always encouraging students to meet each other and to get to know each other. I would fear making a channel for a class I don't teach. Like, they'd be like, hey, I heard your Discord has a channel for my class. I'd be like, yeah. But you're free to talk about other things in the general chat or the unassigned chat and say, hi, who's in this class? We want people doing that. I wouldn't want to make it like kind of official, because then I wouldn't want someone to be like, hi, so your Discord has my students meeting up? I know. I'd say they just meet. Like, no, like literally I want to, anyways. I want students to meet, but I'm not going to make an official catalog question. Okay, and then let's put here BAS 320, indicator variables, birth weight, and education. Okay, let's go take a look at this. Nice job. I like it right there, Kaya. Awesome, Leo. Keep helping out. Thank you, Leo. 100 points. Let's go do the catalog question here, and then we're going to do some 320. So stay tuned for 320. We're going to do the catalog question here real quick. Catalog question. Sales catalog company. Got it ready to go. Here we go. We're doing the catalog question right here. And with the catalog question, it's all about confidence intervals and what do these confidence intervals really mean. So let's take a look. Every interval will have two components to it. It'll have a what at the center, starts with an E, and then it'll have a ME. So every interval I talk to you about in this class will have two components. And the two components, which you can see over there at the 90 and the 2%, every interval is going to have an E plus or minus an ME. So what estimate? Great job, Leo. 100 points. Estimate. And that's at the center of the interval. So this is also called the center and plus or minus. And like the interval is created by the margin of error. Does that make sense? So the center of this interval is 90, like your best guess. Like the estimate is your best guess. It's like when your friend says, I'll be there at 2. That's the center of your friend's interval. But then your friend is going to give you a margin of error to say, well, but I might be off by about 5 minutes. That's their margin of error. Well, 2 p.m. plus or minus 5 minutes. Because every estimate has a certain amount of uncertainty. And so what we're doing right here is we're trying to figure out the proportion of orders that arrive on time. In our sample, and this is the way this one was written, our sample proportion, which is the center of the interval, was 90%. This is all synonymous right here. I'm going to disappear for a moment. So then we'd have plus or minus, plus or minus. The remainder of this in notation is a z-score, square root p hat q hat over n, and they're telling us that this was equal to 2% right here. Like that side of the equation, the plus or minus z-score p hat times q hat over n square root is equal to 2%. The center, and this is also known as the margin of error. All of these things right here are synonymous. Like everything down here is a margin of error. And then everything on the left is the center, which is our best estimate. We estimate that it's about 90%. We are uncertain that it could be off by about 2%. So what does this mean? Would this be true because the margin errors? Would this be true? Let's look at it. Between 88 to 92% of all orders arrive on time. Well, that's stating it. What are we missing when we give confidence intervals? Anytime you give a confidence interval, you should always give a what for your confidence interval. It's kind of close because it is talking about all orders. So that's what the interval is trying to estimate. But every confidence interval needs a what with it. Whenever we give a confidence interval, we should always be giving our what for it. And so we should always give our what for our confidence interval. Every confidence interval will always need a level of confidence. Does that make sense? It implies certainty. Yeah, it doesn't have confidence level on it. The statement is not correct because great job, Leo, right there. It needs a like I am 95% confident that the true proportion of, then it would be right. So that implied certainty right there. So it wasn't correct. Let's look at this one right here. 95% of all the random sample customers will show that 90% of orders arrive on time. Tell me this. In notation, what is the sample customers that arrived on time? So it's, let me see here. These answers are weird. Much less than 95% of the random samples. All the random samples. No. So it's saying if we state whether, 95% of all random samples of customers, like if you were to random sample multiple times, are we making statements about randomly sampling customers? In this chapter, we are making statements about all the orders. So the problem is, and I don't love, this one's not a great, like, this one's amazing. This first one's a great question. What's up, Kelton, Stat Nation? Let's go. The second one right here is not going to be correct because much less than 95% of the samples will show exactly 90%. It's not a really good theory question to review, but there's the answer to that one. That's not the best theory question. It's just wrong because it's talking about the sample. One can be 95% confident that the true population parameter of orders that arrive within 3 days is between blank and blank. Let's check our right interpretation because maybe that's right. Our correct interpretation that we use, which there are different ways to do it, is to say, I am blank % confident that the true blank is contained in the interval blank to blank. We need 4 components right here. Seems true, right? Let's check for the 4 components. Does it give the confidence level? One can be 95% confident. Does it talk about the parameter, the true population proportion? Does it give the interval? It does. This statement is correct. Great job, Leo, right there. So look for your 4 components. The 4 components being, check the slide again. 1, it gives a confidence level. 2, it talks about the parameter of interest. We're trying to estimate the true proportion of orders that arrive within 3 days. And then 3, it gives the lower bound and the upper bound. Those are the 4 things needed for us to correctly interpret an interval. So this is a correct interpretation right here. And that's got it. One can be 95% sure that between 88 to 92% of the orders placed by the sample customers, this is the one I thought we had a moment ago. This one's a decent, tricky question because you look and you say, there's my confidence level, there's the interval, but this is not the what. That is not the what. So we need that thing right there to be what? That last thing right there when it says the sample customers right here, when it says one can be 95% sure that between 88 to 92% of the sample customers' orders placed on time is in this interval. This is not the parameter of interest. What proportion of the sample customers' orders arrived on time? Look at what I've written on the screen here. I've taken this and translated it over here. What proportion of the sample customers' orders arrived on time? Look at the notation. As we've practiced our notation multiple times, know what p hat is. What proportion of the sample customers' order arrived on time? Because we know this. We know our sample. We took data on our sample. So what percent of the sample customers' orders? Not between. So think of this. We talked to, this is the way the question could also be worded. Like, let me give it to you this way, Leo. We talked to 200 customers and 180 had their order arrive on time. So think about that, Leo, right there. That could be this question. It might not work out exactly the same. But we talked to 200 customers and 180 had their orders arrive on time. And then that will work out at least for p hat the same. Because p hat is what's at the center of the interval. It's your best guess of the truth. So we know what p hat is because we have to use that to estimate. Does that make sense? We know what p hat is. P hat is the sample. Exactly, 180 out of the 200, so 90% arrived on time. And those are just made up numbers that might be close to the real answers they're giving. I could actually double check real quick. No, it's got to be a bigger sample than that. I'm trying to figure out what was the sample size by just guesstimating at this. That's about correct. That's about correct. We need a little bit smaller. So this would be 810. They sampled about 900, maybe closer to, I'm just guesstimating. Oh, there, that's basically it. This uses chi-squared too, so it's a little bit non-symmetric. But so they had about a sample size of 800, it looks like, with about 720 conforming. If we go ahead and do our mathematics for it, we'll probably find this uses a chi-squared distribution, which is not symmetric. Close enough, though. When you see this is about 92%, that means we're basically finding the right answer. So it looks like, in truth, if we were to solve this as a problem, it would say something like, we sampled 800 customers and 720 of them had their orders arrive on time. So we would know, the whole point of this is, we know 90% of the customers had their order arrive on time, because that is p hat. Like we're literally talking about p hat right here, which is 90%. That is the sample proportion. So it's just, we know this, that 90% of the sample customers had their order arrive on time. There's a 95% chance that on any given day, no. We're not talking about a given day. We're saying I am 95% confident that the truth for all time, which is kind of sounds crazy. We're making a truth about the population. So this is not correct. The confidence interval is an estimate of the, nope. The confidence interval refers to the probability of the interval containing the population parameter. So we're not talking about a singular day right here. The problem right here is in the interpretation on there's a 95% chance that on any given day, we're trying to estimate the truth of the population for all packages, not on a certain day. So good question right there. You have to watch the parts of it and see which part the error is on, whether they're giving like certainty right here and not doing the confidence. I got one of the correct interpretations. But yeah, this is a great question right here to make sure you understand to say, I am blank percent confident that the true blank is contained within the blank. Yeah, it's pretty similar. There's similarities. Definitely. Great job, Leo, right there. We only have one more question right now, so bring those questions because we only got one question left. Let's go back here. Okay, great work. We only have one question. So if you have a question right now, it's time to ask it because we only have one. We're about to do indicator variables with birth weight and education. Okay. And let's go check this out. Here we go. Okay, let's open up a new sheet right here and do some indicator variables to finish the homework. Or yeah. Great job, Leo. Excellent work. We're going to pull up the data. EX. I think it's like EX. Oh, we got a low red class. Red class. And is it... Was it? Davis, if you're here, let me know. Davis, we're going to work on this. Tell me which one you're working on. I'm going to pull up the EX. What's the EX8? Birthweight. There it is, EX9. Birthweight. And let's call it baby. There we go. We got... Oh, really? I just called it that. Nope, we don't want to do that. Awesome. EX9. There it is. And we're just storing an extra copy of it. Easier to talk about it if we just call it that. Extra thing right there. And... Oh, did I just... I made two versions of it. There we go. We're good. So now when we look at this, we are basically predicting birth weights of babies. It's good to kind of get an idea what you're looking at. Birth weights of babies look like this right here. A gram, which these are, is equal to 450 grams is 1 pound. So if you want to look at the pounds of these babies, there's the pounds of babies. We can just divide by this, and you can see the centrality of the data is around 7 to 8 pounds. A bigger baby is about 10 pounds, smaller baby about 4 pounds. So understanding, yeah, I can get very close, Leo. 5 days away. 100 points. So just want to know what data we're looking at first right here. We also want to understand the distribution. Let's go to bar plot of baby high school, mother high school education. We got to do a table of it. We can just plot it. So here's the high school education of mothers. Kai, good to see you here. And these are the high school education, or the education. We got some below high school, and college. I know, right? Getting so close. And I think the other variable we were looking at, tell me, Davis, does it have gestation in there? And I probably need to send in an announcement because you might have got the right answer. You might have the right answer, and there might be just problems with the quiz. So we'll take a look here, and we'll see if you're getting the same answer I'm getting. What we want to predict right now is we want to predict the birth weight of babies. So the first thing to look at right here is let's look at whether or not a mother is smoking. So we're going to predict birth weight of a baby, which is the Y variable of interest, tilde, these are the X variables. Let's look at smoking, and data equals baby. So we're going to do a summary of our model right here to see the coefficients, and just tell me, what does this mean right here? This right here is the difference between a mother who is never smoking, and I'll show you why it's never smoking, because there's 2 levels to smoking, and never is the reference level. It's reference because it's first alphabetical. So this negative coefficient means mothers who are smoking now, and remember this is grams, who can interpret what that would mean? And if you're 2-1, you might be able to figure it out. This is a model predicting the birth weight of a baby in grams, and we have a coefficient for smoking now. Just think about smoking and birth weights of babies, and you'll probably figure out what it means. Where we're predicting the birth weight of a baby for a mother who is smoking now versus a mother who is smoking never. So what does that negative coefficient mean in the model when we say this is the estimate for the coefficient? And I'll show you something 201 here in a second that you'll be like, wait, what? What does that negative coefficient mean? What does that negative coefficient mean? And Davis, this will be a big help too in here a second, and we're going to make your exact model and see if we're getting the same answers. But what does that negative coefficient mean? What does that negative coefficient mean? We're predicting the birth weights of babies, and we have a negative coefficient for smoking now, which means we're comparing it to smoking never, because that's what this coefficient right here, the smoking now coefficient, compares to smoking never. So we'd say 2 mothers where 1 mother is smoking now and 1 mother is smoking never. We just got two mothers right here. One is smoking currently, and one is never smoking. Correct, Davis. Basically, 100 points, Davis. It means two mothers where one is smoking now and one is smoking never. The mother who's smoking now is expected to have a baby that is born 271.8 grams less than the mother who's smoking never. It is the expected difference between two mothers where one is smoking now and one is smoking never. We expect the baby for the mother who is smoking to have a birth weight that is this much less. Does that make sense? So it's like, generally speaking, mothers who are smoking give birth to a lighter baby. So now when it comes to mother's education, good job. Oh, you don't gotta call me sir. I'm just Brian. When it comes to mother's education, we can do the same thing right here and run the summary on mother's education. But what are we missing from this output? So this is a key thing to know. What are we missing from this output right here? Which of these levels? We have college, high school, and what are we missing? So college, high school. Let me look at your question because we're going to try to make it exactly. Between the average person, let me take. I'm going to take your thing. What are we missing right here in this output, Davis? And why are we missing it? And we have open questions, so drop those questions in the chat. So what are we missing in this output as I try to make... What are we missing in this output? What are we missing? What are we missing? What? Look over here. And then what are we missing in this output? What are we missing? So we got education college. We got education high school. And what are we missing over here? And why? Important key concepts to indicator regression. We're missing one of those. And which one are we missing? And then we'll look at the question. Which one are we missing? So which one are we missing, Davis? We're missing below high school, correct, because this is what is called the reference level. So the reference level is the first alphabetical, just like for the smoking problem right here, it was never, and that's why never didn't appear in this output. Look how never's not here because it's the reference level. Hey, Kayla, great to see you here. Working on 320, so ask some more I think you're 320 also, right? Wait, I'm trying to think. I got a lot of Kaylas, and I think you are a 320 Kayla. No, whoop, that's all right. Working on 320, and so ask questions, or I'm pretty sure 320. Ask whatever question you want, though. Goose got a lot of Kaylas in 320, and so now when you look at this right here, we're comparing the birth weights of mothers to the below high school education level. And these mothers are giving birth to heavier babies compared to below high school. So two mothers where one has college education, one has below high school education. The mother with college education is expected to have a birth weight that is, maybe 2 weeks. We'll find out. Terry will be releasing it soon. Good question, Kaya, right there. The mother who is in college is expected to have a baby that is 186.3 grams heavier, about half a pound, about 0.4, maybe 0.5. A mother who has had high school education versus non-high school, below high school. The mother who's had a high school education is expected to have a birth weight of a baby that is 221.8 grams heavier than the below high school mother. So these are the expected differences between two mothers, and we're comparing college to below high school and high school to below high school because remember, below high school is the reference level. So the question is asking about, okay, of course, Kayla. Well, there you go. Now I know the picture. Of course, Kayla, of course. Good to see you here, Kayla. I was like, yes, of course. That helps right there. The question is asking about what's the difference between the average birth weights of between babies born to mothers who graduated from high school and who haven't. So I made a model predicting birth weight. And so if we're looking at those who graduated high school right here and those who haven't, this should be it right here. Is this what you did, Davis? Because this should be the value. And I think there's a problem with the quiz, and I think I corrected it for my sections because a student told me about this one. So is that what you're getting right there? Let me know. What do you get for yours? Is that the coefficient you're getting? Because that's the coefficient I'm getting. That's what it should be, theoretically speaking. Like, theoretically, that's the right answer. What are your thoughts? Is that the answer you're getting? And Kayla, ask away. Kayla, I'm sorry. I'm used to seeing, I'm like, which Kayla is it? Which Kayla? I'm like, of course, Kayla. It's Sneeze Kayla. Is that? Yes. I'm getting ready for the wedding, so my mind's like so busy. We got family coming in on like Thursday. Family will be here in 3 days. Oh my gosh. My parents, as we finish off this question right here, it's open for on questions too. My parents got Super 8, but my parents got a Super 8 down the street for their hotel. Sorry, Super 8, but we looked up the reviews of the Super 8 and it said like roaches. So exciting. Oh, yes. Oh, yeah. Yeah. Well, which one is it, Caleb? Drop it in the chat and we'll talk about it. Yeah. Drop it in the chat and we'll do that. Here, we'll do that section. Davis, let me know. Does this make sense, Davis? Does graduate high school include both the high school? It's hard to do that. I'd say reading too far into it because, yeah, it was a Roach Motel, right, Kaya? And I told my parents, I was like, Dad, I will pay for you to stay wherever. I will pay for you to stay wherever. Let me take your question, Kayla. I was like, Dad, I will pay for you to stay wherever. It's fine. Like, my wedding gift to you is you're not staying at a really scary hotel. Not happening, Dad. We'll look at that next here. How do I plug in 2 for party size on a specific day? Good stuff. Here, we'll do that here. Nice. You got it. And so, Davis, let me take a look at this question here. And let me see. I'm going to go take a look because I think this... Oh, gosh. I'm going to fall asleep, everybody. Oh, my gosh. I slept. I swear. I promise I slept. Let me put up this real quick. Make sure. I'm going to go over here. Let's go take out the indicator quiz. Make sure. I might have changed this for our class. And so we are getting the questions. So many questions can be drawn from. Okay, so I'm grabbing from the banks. And the question was birth weights, graduate high school. Okay, I'm finding the question. And then we're going to make sure. Problem is I changed it in my class. We might need email instructors. Really? It better be over here. Wait, what? Graduated. I'm going crazy, everyone. Here it is. What is the difference in average birth weights between otherwise identical mothers born to a mother who graduated from high school and who have not? Round to the integer. Okay. Okay, I think I still have the old answer, and I don't know how they're finding that because that doesn't make logical sense. Mine has an update to it. I feel like just sharing the answer because I think this is wrong. I'm just going to share it on the screen right here and give away one answer right here. So, Davis, if you're watching, I would suggest the first answer, and I need to contact instructors about this, but I'm showing the answer right here, showing just one of the answers on the quiz. I would suggest this answer. This is the one I believe I corrected when I was contacted by a student who got it wrong and said, hey, Brian, I'm doing what you said. Everything's working. Because according to, now I wouldn't put this answer in if you're in another class. What should we do right here? The mothers who graduated high school, just the mothers who graduated high school versus those who did not. What is the expected difference in birth weight? So just answer round to the nearest decimal. Use this output right here to tell me what is the expected difference, but don't put this in if you're in another class. If you're watching this video, you're in another class, you're working the same problem. If you're in another section, I wouldn't put in this answer I'm about to tell you right here. But what is the answer that I want you to say? From the output right here, what is the expected difference? To the first question, what is the expected difference between 2 mothers where one graduated from high school and one did not? The expected difference would be what between those 2 mothers according to this output. But don't put this in if you're in another class. We'll show you the answer you probably need to put in. The expected difference would be what? It's not bad if we give away one answer. What would be the expected difference? Correct, Kayla. Yep, that's it. There it is right there. That's the coefficient, the estimate of the expected difference. Kayla, great job right there. All the buttons. So that's the expected difference right there. But don't answer that if you're in another section. That answer right here, rounded, and you see there's a margin of error on it. So it would 221.8 would be the right answer. This is what I have for our section. I think I kept the old answer because I just didn't see how it was being gotten. Because I'm getting that answer right there of 221.8. If you're in another section, put 95 and you should get it right. I hate to give away one answer, but I'll be emailing about this. It's not bad if we give away one possible question that you could get, but this question just doesn't seem to be evaluating correctly. Okay, let's go take a look at the second one right here. Okay, this question coming right up. Thank you, Davis. Keep asking questions if you got them. We'll keep working away on it. Kayla, it is time for more questions on indicator regression, solving implicit lines. So BAS 320 indicator variables, solving implicit lines. Let's go take a look at it. Here we go. Okay, so solving implicit lines. Let's take a look right here. If the overall regression equation is, okay, there it is. Bill is equal, let's grab this. There it is. Bill is equal to this. We need to take the whole equation. Okay. So here it is right here, Kayla. And you said, predict the bill for a party of 2 on Sunday. So these variables right here can only turn into what or what, Kayla? These variables are indicator variables, and they can only, like, they're just like Mother Education College. These variables are indicators that can only turn into what's or what's. So we should know indicators can only turn into what's or what's. Zeros or ones, right? So let's put a multiply next to everything here to make it look a little bit better. Might not it probably didn't have multiplies there to begin with. We're going to add in some multiplies. So now, when we solve this, if we solve for Sunday, then how would we write this for Sunday? How would we write this for Sunday? In the model predicting bill for... I believe so. Look, Davis, good question. Keep those questions coming to 320. Keep those questions coming. We'll do that next, Davis, you bet. How would we solve this equation for Sunday right here? We've written our line, we've written the equation, and how are we going to solve that for Sunday right there? Like, first, let's solve for Sunday. We'll worry about the next part next. We plug in a 1. So we plug in a 1 right here. Then we plug in zeros over here. And then it says for a party of 2, we plug in 2, and that should do it. So bill, there should be the bill. Does that make sense there, Kayla? Let me copy this right here. I'm going to make it so we can see it at the same time. Does that make sense, Kayla, right there? We plugged in the values, and so bill is, so we plug in 1s. You plug in 0 for all other days besides Sunday and 1 for Sunday. Davis, great work. Exactly, because that indicates it is Sunday. So you want to basically indicate, what day am I indicating if it's not Sunday, not Thursday, not Saturday? This is Thursday, Friday, Saturday, Sunday, the days of the week that are only the weekend. So if I say it's not Thursday, it's not Saturday, it's not Sunday, I've indicated it's what day. I mean, it's the reference level. I haven't really indicated it's a certain day. But now this model is solving for what day? Friday, the reference level, exactly, because we put 0 for all the indicators. If you put 0 for all the indicators, you're saying it's not Sunday, it's not Thursday, it's not Saturday. By putting a 1 here, you're saying it is Saturday. By putting a 1 here, you're saying it is Sunday. All the other indicators have to be 0 then. Does that make sense how indicators work? They're like a light switch. It is either Sunday or it's not Sunday. And as soon as it's Sunday, if you say, yes, it's Sunday, it's not Thursday, it's not Saturday. Yeah, no worries, no worries. And just plug in the numbers, let it solve it for you. It's just going to solve the equation right here. So at this point, we're just solving for Bill by adding up the numbers. And yeah, and it would make an implicit line when we do this right here too. And Davis asked another great question right here. I haven't even started the assignment. I'm usually almost done. No, you're fine. You're fine. Keep asking questions. Kayla, I think you're getting this content very well. Also off topic, everyone's name is always mine. You know what? Let's do this. Davis, you are a moderator. So Davis, we're glad to have you here. Davis, I usually only moderate people, add mods during class, but Davis, you're now a mod. So your name is Blue. Thank you for asking, Davis. We're glad to have you here as a mod. Maybe you're like, I will pretend to know all the stats now, but you got this. You're a mod now. Good to have you here. Your name is now Blue in the chat. Next time you type, it'll be Blue. Let's look at the next question. We're going to head back to the main screen, do another segment on another question. Here we go. Welcome to the moderator team, Davis. Next question right here is, yeah, thank you, Kayla. Next question is about some differences. Let's take a look. It means if we have someone randomly join a stream and start saying things they shouldn't, you can delete chats. So you can remove chats. We really don't, it's not common that we need people to moderate. It happens every once in a while. Like rarely it happens, but that's why we have mods. And then it also lets me see if someone's my student. Like Davis, with you joining in now. What course do you teach? 201, 320, 474, 475. So here's my general courses I teach. God, no, you didn't email, did you? A few people have been emailing me lately about joining the courses. Those are my general courses I teach. Then, yep, 475. 475 is a lot of fun. Here's other courses I have taught in the past. And then I might teach 471 in the future or 479. I mean, just a lot. I joke I don't have a stats degree, and I'm like, can I just take the courses I teach? Because my undergraduate's not in statistics, so I'm like, can I just like sign up to my own courses? It's almost possible, Caitlin. That's what a lot of people joke. They're like, yeah, I took all Brian Stevens courses. It's like 50% of your courses could be my courses. And I'm really excited because I'll be back at UT like within a year. So if you're freshman, sophomore, you'll probably have some in Stevens class, in Brian Stevens. In-person classes with Brian Stevens. I've got some big plans. So Kayla, you'll be at the law school, so you'll have to swing by the office and say, hey. We'll try to have Chelsea come by. I always want Chelsea to come by and swing by. Not taking 474 until I can get you. Oh, well, thank you so much, Davis. Well, Davis, I'll be doing live office hours anytime. Davis, you're always welcome to just swing on by, do some office hours, ask questions. And I will say this, we have some amazing teachers like Adam Spambauer, Adam Petrie, you name it. We've got a lot of people working super hard. Terry Higgins. We got so many people like Dr. There's one person I really missed. Dr. Chung Un Lee. She was absolutely amazing. Another college swooped in and picked her up and said, we're taking your amazing professor from your department. But we have tons of amazing professors. Dr. Nana Bryant. I try to say doctor when someone's a doctor. Well, I should have said Dr. Petrie. Did I say Dr. Petrie? I might have. Adam Smith is not a doctor. Yeah. Terry's great too. Terry is great. I will say this about my department is everybody's working super hard. We're having a retreat, which I'm not going to be at, literally student focused. A lot of departments are like, our department focuses on publications and H-index and, what journals are we getting into? That's important. That's a university does. But then the retreat is focused on students. And that's thanks to our department head, Dr. Mike Galbraith, who is very, very student focused. So I'll get the next question loaded up here. But literally the focus of our retreat is cosplay. Do that, Kaya, do that. Cosplay as Brian Stevens and then show up and they'll be like, who are you? Be like, I'm Brian Stevens. They'll be like, oh, only Brian Stevens would say I'm Brian Stevens. Like, Kaya, that's awesome. No, that's, and Kaya, join in 320, all these great things, and you'll see this. Let me show you something right here. We got the next question. Let's say making models. We'll call this making models. Let's go do this next section. I'll show you something super cool here. Yeah, I'll do some assignment 9. Kayla, get an assignment 9 question loaded up and we'll take a look. I'd like for you to see something though. So if you're in 201 this morning, when we make 95% confidence intervals, how many standard errors do we go out? If we make a 95% confidence interval, how many standard errors do we go out? So basically we go out this. How many standard errors do we go out? If we go 68, 95, how many standard errors do we go out? If we make a 95% confidence interval, so if you're in 201 and 320, this will apply. How many standard errors do you go out? Oh, wait, careful, Kayla. You're thinking of 99.7, 68, 95, 99.7. You might be doing 99.7, 68, 95. Not 3, because that's a 99.7, 68, 95, 99.7. Too good practice right there. So what if I told you, Kayla was just making sure everyone's listening. Kayla, another points on top of that. What if I told you I could make a 95% confidence interval for this coefficient in my head? Do you believe me that I can solve a 95% confidence interval for that coefficient in my head? The numbers aren't so pretty, but I believe I can do it. Would you be like, Brian, you got this? Or would you be like, how in the world are you going to solve that in your head? Well, we go out how many standard errors? Like the slide literally says, just tell me again, it literally says we're going out how many standard errors? We're going out 2 standard errors. So do it with me. What is 2 standard errors? Just tell me what 2 standard errors is. That's a standard error right there. So what's 2 of those? A standard error is 61. So what's 2 standard errors? So remember, we're going out 2 standard errors. So what is 2 standard errors? What would be 2 standard errors? 2 standard errors? Oh, no worries. Yeah, no, go grab the calculator. Type it into R, grab the calculator. 2 standard errors would be what? Would be 2 standard errors. Take our hand to go. Oh, we'll do it. Yeah, we'll do it. There's 2 standard errors, right? So you would add and subtract that to your estimate. So you'd say plus this, and you would say minus it. And we've just created a what now for the estimate? If I go out 2 standard errors, we just created a what? Think to 201. This is 201 now. We just created a what? We'd say, the true coefficient is somewhere between 99.8 to 343.8. We just created a what for the estimate by going out 2 standard errors, which standard error is the amount of uncertainty we have. We just created for 100 points a what for the estimate. And great job, Davis, right there. A confidence interval. And here's the thing, Kaya. I can just go say confident, and it did all the work for me right here. Now, it does it more exactly. It does it to the decimal place accuracy, but it was basically 100 to 343, and there's the exact numbers. But all I had to say was confident. So that's why we don't have to work these problems by hand, but I should know what it's doing. Does that make sense, Kaya, right there? Like, we're basically going out 2 standard errors by going plus or minus, and this is a 95% because 95% is contained between those numbers, 2.5 to 97.5. I wish it just said 95% confidence, but that's the lower bound of a 95 and the upper bound. I am 95% confident the true coefficient for mother's high school education is contained in the interval 102.08 to 34.6. And we basically did it right here. This will do all the decimal place carrying and the exact calculations. So we can kind of do it. I enjoy, yeah, exactly. Like, and this is what we would expect the differences to be between the mothers who have a high school education versus those who don't. And we're going to look real quick at Davis's question. Then we're going to do some, Kayla's going to help us out with the assignment with some of those questions. Davis was asking, and Davis said he solved it too. So Davis, 100 points. Great solve right there, Davis. In the model predicting bill from party size and weekday. Okay. After accounting for party size, what is the expected difference between Friday and Saturday beers? Friday. I love it. And so what we want to do here is we want to go and be careful. I'm trying to think if we use a different data set for this. So there's the tips, right? I want to go here to tips data set. I'm going to go by it 10 times. Really? There it is, EX2 tips. Okay. I think it's actually tips data. There it is. So we're going to the tips data. Yeah, let's do it. Grab me an assignment 9 question. And there it is. Okay, so we are going to predict. So imagine you're a waiter or waitress, Kaya, and or waitress, and you are trying to predict how much your tips will be. So you want to predict, or you're going to predict the bill size. You're going to predict bill. That's the Y variable of interest. I'm from New York. Do I sound like Canada? Sometimes my dad's actually from Canada, but I'm from New York. Party size. So our restaurant now we're managing the restaurant. We don't care about tips anymore. We care about the bill because we're a manager at the restaurant. We care about how much is our bills. It says party size is not found. It might have a lower, because I didn't put the data frame. Y tilde X, comma data equals. You have to put your data frame, and there we go. Sometimes New York. And so we are going to look at the bill, and this is the prediction. So what we're looking at right here is 2 parties that are otherwise identical, but differ in their party size by 1. We must work at a Sonic or something maybe, because the expected difference in the bill between 2 parties that are otherwise identical but differ in their party size by 1, we expect their difference in bill to be $5.56. Does that make sense right there? The interpretation of this coefficient is 2 parties that are otherwise identical. I went to school in Minnesota, and half the kids had Canadian accents. So, Minnesota. I got off the plane. They're like, "Hey, how you doing? And welcome to Minnesota." And I was like, "Wow." I was like, "I'm not used to this." And they're like, "You're not from here, are you?" And I was like, "Nope. I'm flying in, not coming back." I mean, I mean, it was a nice place. 3M was awesome. So 3M, shouts to 3M Leo, in Minneapolis, Minnesota. Um, but two parties are otherwise identical, but differ in their party size by one. The party that is larger is expected to pay $5.56 more than the other party. Now, the question is, what about after accounting for party size? Like, with that said, two parties are otherwise identical, but one is on a Saturday. And whoa, wait, why don't we not see Friday? Where the heck is Friday? I mean, we saw Friday a moment ago. Can anyone explain to me in the chat, for those who know 320, where's Friday at? What's going on? Where's Friday? Friday. I mean, I saw it. I saw... What is the reference level? Great job, Davis, right there. We don't see it because it's the reference level. That's exactly right. So Friday is here, but everything is going to be compared to Friday. So when we say the expected difference between Saturday and Friday, that's actually this coefficient right here. It's basically 1. So this is just a bar chart showing us the occurrence of days, the amount of bills that were on Friday, Saturday, Sunday, respectively. And we would say the expected difference between two parties that are otherwise identical, i.e. same party size, but one is on a Saturday and one is on a Friday, is $1, basically 99 cents and 0.9. That's a dollar for all intents and purposes for interpreting. Yeah, that's got it. Yeah, I've been to a lot of golf events on MN hosted by 3M. Also caddied for a lot of 3M execs at my... Oh, yeah. Well, I hope they're pretty nice. Everyone at 3M was super nice for me too. That was probably a pretty good thing, Leo. Probably pretty good. You'd be shocked. I'll back to the main screen here, and if you have a 320 question, drop it, or 201. 320 might start working on the assignment. Let me get the assignment loaded up here. But when I was in college, I waited tables, and waiting tables actually made me a lot more than a lot of my first jobs out of college. So when I was waiting tables, some weekends I could make 300-400. Busy weekends at Cheddar's, like busy weekends. And yeah, like that was nice work right there. It was super busy and super crazy. Like then you just have people getting mad at you for little things, like, you know, it's like, my soup wasn't hot enough, and you say, I will get you some new soup, and then they don't leave you a nice tip even though you give them like an extra bowl of soup, because that's usually just the fix. It's like soup costs like nothing at the restaurant, like, so if it's hit the table, you can't return it. So you just say, let me get you some new soup. And they say, here, take this one. You say, oh, no, just relax. Eat away on that. I'll get you some new soup. Because you just want to make them happy, you know? You want them to come back. That's the goal of it. And I really hate it. I've worked at some places, some restaurants that are more like, no, you got to take that soup and throw it out. And I'm like, I don't, you know. I mean, I guess some customers could abuse the process. Be like, my soup's not warm enough. And if I say that, they give me new soup, 1C. Service positions where you get tipped are the best. You can make so much. Yeah, exactly. It just depends, though. It's tough. Oh my gosh. But I hate waiting tables. I had bad dreams. Oh, server nightmares. Yeah, no, server nightmares are real. Kaya, oh my gosh. No, server nightmares are real. Oh my gosh. Kaya's exactly right. I had server nightmares too. Like, you dream like you go into the back and a table's been waiting. You haven't greeted a table in like 20 minutes. They've just been sitting there, and someone's like, Brian, your table's been sitting there for 20 minutes. You haven't talked to them. Server nightmares are real. I actually one time got up and started walking around my room. My mom came in and she was like, what are you doing? I was like, I'm looking for table 5. And she's like, what? And I was like, wait. And I was like, huh, what? And she's like, you said you're looking for table 5. And I was like, wait, what? She's like, I think you're dreaming. I was like, oh, what? Server nightmares are real. Server nightmares are real. Ugh, I haven't had one of those in forever. I forgot the ranch. Oh, just to have ranch ready. I think sometimes we literally just had ramekins of ranch ready to go, like in the refrigerator. You just walk by and grab a ramekin of ranch, or you just got the little, everyone knows that little thing. You pull the tab back on, you just go bloop. You just grab a ramekin, bloop. Or you have a plate, you put it on a plate with a napkin, you put the ramekin on the plate, you hand the plate with them to them there. You put like 3 ranches, like bloop, 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 and then just hand them the plate. I mean, you don't do it there. Yeah. So you got to just be like that. And a lot of times I would predict drinks that I'd be looking and I'd be like, they look like some sweet tea. So I'd get like a sweet tea ready to go and I'd have it like on the corner. And I would, as I got, the last thing on this, and we'll do 1C here next, Kayla. But as I did more and more waiting tables, I'd get more like, let me predict the drinks people are going to have. I'd be like, they look like a 2 water and an iced tea. And then they'd be like, yeah, we'll have a water, I'll have a water too. Because water's just super most common drink at restaurants. And then probably the second most at our restaurant was iced tea. And then some soda would be third place. So I'd usually be like, that's a water, iced tea. And I got a few of them right. And I'd have the drinks like ready to go on the side. And they'd say their drink order. And then I'd like walk around and be like, bloop, bloop. And then if I didn't get it wrong, like I'd probably be thirsty. I'd be like, I'll just drink the water and just bring the drink to the dish pit. Like, I'd just go to the back with the water I got wrong and just be like, drink water and then put it in the dish pit. But yeah, I wouldn't make food though. I'm not making food and then put it back. But yeah. Hey, Lillian, great to see you. We're about to do 3C. Water with a shot of tequila. They look like a shot tequila table. I don't think the bar would let me put in a bar order as a prediction. My predicted model on. It's funny how a lot of these things relate, like predictive modeling. Like I wouldn't do predictive modeling. This is assignment 9. We're doing 1C right here. So I wouldn't do predictive modeling on what drink, unlike bar drinks. Bar would not be happy about that. Okay, let's go look at some 1C right here. All those server nightmares are over for now. We need to load in the environment. Someone said they had problems loading this in. Okay, it loads. Everything's good for me. 1B, 1A and 1B. We can do that next. You bet. So let's take a look. Lillian, you got it. We got 1C to start. We'll do 1A and 1B coming up right after this. So 1C says, because that's the one I think Kayla said 1C. Let's take a look. 1C says, let us compare average demands for rainy days and non-rainy days after accounting for temperature. So what is needed in this model? If it says, let's compare the weather, and that weather variable is called, here, let me remove everything out. We got bike data, homework 9 bike, and we have weather. So how would we include rainy and non-rainy days after accounting for temperature? Be careful, temperature has it's not temperature, it's temp. So what would we write right here? We want to make a model predicting demand, and then what are my X variables of interest? What are my X variables of interest? It says after accounting for rainy, non-rainy, which is weather, and accounting for temperature. So what should I put in? It basically tells you right there too. What should I put in right here to make a model that is going to predict demand? This is the Y variable of interest. That is the Y variable. This is where my X's go. Exactly. And this is the way it looks as like a general format where we have the Y variable of interest and we have X1, X2. So these are the Y variables of interest, X1, X2. Let's put back in demand right there. And then it doesn't matter, Rock knows which order we put them in. We can just go right here and put the following variables. And it won't autocomplete, so watch out. But now we want to go data equals homework 9. There it is, homework 9, bike. Now make sure it runs. If it doesn't run, there might be a typo, or you might not have loaded in the data frame. This was loaded in by doing the load data up here at the very top, which has the data you're working with. Make sure to use the following data, have that downloaded, and be using it. So when we look here at question 1C, it says examine the results of the summary as well as the visualized model for this model. Use the regression summary to answer the following questions. So when we look at this, we should always start by visualizing our model. And what do you notice right here? This is a model with what's. Like, just explain to me visually what you see. Just understand what indicator regression does. This is a model with what's. What do we have right here? This is a model with what's. This is a model where you have pretty much 2 lines, exactly. 2 parallel lines. Great job, Lillian and Kayla are here. 2 parallel lines. One line predicting the demand for rainy days, which is this one. One line predicting the demand for non-rainy days. And look at this right here. It's like if the temperature is 5 Celsius, this is our prediction for a rainy day, and this is our prediction for a non-rainy day. And so this distance right here, let's look at it. This distance, I want you to tell me about how much it is. We'll go grab a new sheet of paper. This distance right here, how far is that distance? I just want you to estimate it. I just want you to take a guess at it. The guess doesn't have to be perfect, but that difference looks to be about what? What do you think? I just want you to guess at it. Don't worry how far your guess is, but just take a guess of how far those are away from each other. How far are those lines, parallel lines, away from each other? We'll see some important, about 900. Let's take a second guess and we'll average them. Maybe it is 900. 800? Okay, let's go 850. I think that's a good guess. Well, what about if we compare the rainy days to the not rainy days? What would you say to me? If I say, let's talk about it in terms of the rainy days. The rainy days would be about how much less than? Like if I said they'd be about 850 less than. Does that make sense? Like if you take two otherwise identical days where one day it's not raining and one day it is raining, then the estimated difference is that this would be about 850 less. Two otherwise identical days? What? Where one day it's raining and the other day it's not raining, the expected difference between those days in bike demand would be about a difference of 850? What? Interpretation right there is what we're going over. That would be the expected difference right there. And where do we see this negative 850? We'll see how close we got in our guess. The negative 850 is going to be where in this? Where is that negative 850 going to be? It's going to be the summary, but where do we... Ooh, we were a little bit too high. It wasn't 850. It was 650-ish. I was trying to get us a little bit lower. I was like, but don't worry. Don't worry your guess. It was a fine guess. Where do you see what we estimated to be negative 850? Though we were a bit off on our guess, but that's all right. Where do you see the negative 850? But it's not negative 850, so just make sure you know that. Where do you see that is it right here. This is the coefficient of the difference right here. That is that difference between the lines. It's negative 655. Not the intercept, but the coefficient of weather rain is the difference between rainy and non-rainy days. Does that make sense? Great work there, Lillian. Good correction. Excellent work. The intercept would be the value when temperature is equal to 0 and we have a non-rainy day. So with this right here, it asks first, is it statistically significant? So is rain statistically significant? Very simple, very easy to go to. Is rain statistically significant? Yes or no, is the no rain statistically significant? Why or why not? So it's kind of, I don't want to say exactly, but I think we're good on this one. I think we're good. Why? No rain, it is because the coefficient has a p-value, the stars exactly, it's less than 0.05. P-value right there, so definitely statistically significant on that. Compare the above differences. Are they about the same? Wait. Compare the above differences and average the differences from A. Oh, we got to look at the differences in A. So now we got to go back here to A. Okay, so let's do 1A. We have to actually do 1A. Okay, so what is the overall average demand for rainy days and non-rainy days and the difference between the two? Is there a difference in average demands? Okay. So we can do this a few different ways right here. There's many, many ways to do this. What we actually want to find, and I'll show you about 3 different ways to do this. The specific coefficient needs to be correct. This one right here. And this is only for a 2 level because then that coefficient right there is the significance of the indicator because there's only 1 level, but that's the whole variable itself. That's the difference from the reference level, and that only works for 2 levels. If we have a 3 or more level, we have to do a partial F, Kayla. So we'll be talking about that a lot tomorrow. And the assignment's due on Wednesday right now. So I'm going to show you a few ways right here. Aggregate demand by weather. Data equals, what's it called? Homework 9. Fun equals mean. There we go. There's one way. That's one way. Way number 2. M save into LM. Here we'll call this MA. We don't need a fun now. And there's another way right here. So if you notice right here, this kind of points to it. Fun equals mean. That tells it what function to run. So it's aggregating by that function. You could actually go and find the median for all these. So you can break it apart by different things, and you can actually make tables super quickly. Like you could do day of the week and find the average. Watch this, Kayla. You can find the average demand for Friday for a non-rainy day. This right here, you can find the median. So super quick to get like whatever you want. You could find the standard deviation of these days like that. So you can get all of this information right here. Like what is the standard deviation for Friday on a non-rainy day? Just like that. Aggregate is a crazy function. It's super powerful. And so we just kind of scraped the surface with it right there. Yeah, it's super. You can add another thing if you want, like holiday, and it'll make a 3-grid table. We might get some NAs right here, but yeah, because there's not enough data for those. But yeah, you can aggregate super crazy ways and get all crazy information. The main thing we should be looking at right here. Let me clear it, and then we'll do this. These are just like 10 ways to do it. Okay. Is when you look at the aggregate right here, it's very clear from the aggregate that right now this model, which is predicting demand, I'm looking at this linear model right here. This is the linear model output. This linear model is predicting demand from weather. And this value right here, which is the intercept, and this works because it's the only variable, is actually the average for what? The intercept is actually the average for what? The intercept right here is actually the average value for what? A what day? The intercept here is actually the average value for a what day? The intercept is actually the value for a what day? Oh, well, it's the average demand for a what day. That is correct. It's the average demand for a what kind of day? For a non-rainy day. It's the average, that is the, because we're predicting demand, and this is if it is a non-rainy day, which is the reference level. And then right here is the what. So this negative 907 is actually the what. So look at this output down here. Like if you understand the connection between these outputs, this 907 is actually the what. And look down here to see what it is. So if you solve it, you can see what it is down there. That 907 is actually the what? The difference. Get job, KP right there. It's the difference, because what we're seeing right here is on a rainy day, we expect the demand to be 907 less. And that's what you see right here. This is the mean for a rainy day, which is 907 less than the non-rainy day. Does that make sense? Like, so that coefficient is the estimated difference between, we don't have to say two otherwise identical because it's not a multiple model we're looking at in this example. We could throw it on there, it wouldn't hurt. But this is the estimated difference between 2 days where one is a rainy day and one is a not rainy day. We would expect the rainy day to have 907 less demand, and that's the average right there, and it's shown. So that 907 is the difference, which is negative because rainy days, and this is the indicator rainy day, is 907 less. So we compare this 907 to the difference we're seeing down here in this model. In this model, we see 655. So 655 compared to 907 is about a 72% difference. So does that sound like a pretty big change to the coefficient? So this one else asks about, is there about a 17% change? What do you think? Are these, like, the coefficient is 655 now, which is the expected difference between two otherwise identical days where one is raining and one is not raining. We expect the demand to differ by about 655. Hey, Terracita, great to see you here. With the rainy day having 655 less demand on average. So is this a large change to the coefficient? It was 907. Adding in more variables has a new coefficient estimate of 655. So there's our original coefficient in the simple regression model. Here's our new coefficient in the multiple regression model. This is a multiple regression. Yeah, so it's a pretty large change. And that's something important to note, is that as you, and great job KP and Kayla right there, as you add in more variables to a model, it'll shift around things. Imagine what happens, Kayla, if you have one, you're making dinner for one kid. You say, okay, dad's watching the other kids tonight, and we're just going to make dinner for this one kid. And you're making pizza or something, and then dad comes home and he says, it turns out the restaurant's closed. We're going to eat pizza with you guys. What happens to your whole model? You're making a hot lunch. So exactly, that's the real experience right there. So all of a sudden, when more variables get added into your model, everything starts to shift and change. You're like, okay, well now we're going to change. Like the one kid is going to eat like different stuff right there. It's like, okay, well now we're going to add these other things to the model, and everything's going to shift in the model. So although we knew what was going on with this one variable, now we're adding in more variables and everything kind of changes. And that's what this is pointing to in the multiple world. because this did have a coefficient of 907, and we see it right here in the simple world. So in the simple world, it has a coefficient of 907, but then all of a sudden there's more variables in the model. It's like, okay, well, now I have a different coefficient because I have to kind of account for these other variables and look at what I do with the other variables in the model. So in the multiple world, things change. That's kind of the key of what this question is getting at, is that you will see substantial changes to your coefficients sometimes, not always, but this is changing. We'll do one more right here. Write out the implicit regression equation. So what is the first thing we always write before writing implicit regression equations? Because maybe the test, when you invite your family over to exactly. You gotta be like, oh, I gotta change up what we're doing. Everything changes. Like, even how you, not saying like in a bad way, but like your example is perfect, Kayla, 500 points, because you're right, because like you might even act differently around like your kids with your in-laws over and stuff. And so the first thing we're going to calculate right here, Lillian, is we're going to write this equation. And the first thing we need to calculate is what's called the overall equation. This is the easy one. So Lillian, great job right there. We're going to write demand equals, right? And this calls LaTeX notation, so we can write an equation all pretty-like. And we're going to say demand equals, and it's going to show it down here. Demand equals. Now, what do we say? Blank, 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 blank. How do we do this? I used to think this was so hard, but once you realize the pattern of this, it's so easy to write the equation, the overall equation. What do I usually say? I say, It's algorithmic in the way you have to do it right here. Very, very algorithmic format. So what I say is always this plus this times this plus this times this. It's just algorithmic. Just go through. This, your intercept, plus this times this. And we're going to make it look all pretty right here. So make sure to just algorithmically go through. And then we're going to change that to a minus because that is a minus. And there, that's got it. There's the equation. Exactly, Lillian. Looks like a good job. Great job, Kayla, there too. You've learned it. It's just this. How hard is it to write the overall equation now that you know how to do it? Like, it might seem like a lot first, like, writing the equation is a lot of work. And you're like, it's just copying numbers. Just copy the numbers. Just this plus this times this plus this times this plus this. Yeah, it's easy peasy. Just take intercept plus this times this plus this times this. There we go. Now to solve for the no rain, how do we solve? Make sure to reduce. How do we solve for the no rain equation? No rain is the indicator. It did, right, Lillian? Once you see it, it's like, psh, but early on I would not have said it's easy. I'll try to stop saying things are easy, but I want people to have confidence, be like, okay, it's just this plus this times this plus this. And how do we solve for the no rain level? We need to indicate it's not raining, or we need to not indicate it's raining. Great job, KP. You got it. Excellent work, KP. 100 points. KP said put a 0 right there, and guess what? It's gone. There it is. That's it. All we did was put a 0, and then 0 times something 0. So how would we make the rain model? So what would we do to make the it's raining model? How would we write the raining model? How would we put a 1? Because that indicates it's raining. That's why they're called indicator variables. That means it is rainy. So by putting the 1 right there for the exactly, so we put a 1 in, and then what will this change about the model? Tell me. This is good review. By putting a 1 in, what does that visually change about the model? And you can see it right here mathematically because we're subtracting a constant. And there's where the constant is. So what will that mathematically change about the model right here? Hence why they're parallel lines. The only difference is the change to the what when we subtract this off. That is correct, KP, right there. And that is changing what mathematically? Conceptually, and this is good like conceptual practice for the test. Conceptually, that has changed the what of the model. Changes the intercept, exactly. And you can see there visually. And that's what it's doing mathematically. It's like, okay, that difference is the difference in the intercepts. And so now all we're going to do is just take this value right here, subtract this, and there we go. There's the new intercept. And if you look, it is going down towards there. We'll take this off right here. Do realize these graphs do not go to 0 sometimes. So you have to be careful saying, that doesn't look like 1544. Well, if you extend it, it would go to there. Indicators influence the intercept. Ooh, Kayla, that's another quote. Kayla, that is close to quote 200, and we'll have to find a really good quote 200. Kayla, that is quote 200. Congratulations, Kayla. That's a well-worthy quote 200. Indicators influence the intercept. I like that right there. Indicators influence the intercepts. That is a premium note to have right there. Indicators influence the intercept. There we go. And I think that's really good work. We might take a break here in a moment. There, we're on to D, but that did most of 1A and 1B. I wish we had a list of quotes. Our phone is actually ringing now. Did they actually fix it? Ring and hang up. If we represent the categorical level, I think we did this one basically. This was up to 1C basically. Does that make sense here, Lillian? I think you might have this. Which level is the reference? Real quick note on this before we take a break here before class. The reference level is always the level that is what? How would you know the reference level? And make sure Brian doesn't misspeak, because maybe I'll misspeak every once in a while. The reference level is always the what level? Alphabetical first, right? Alphabetical first. Another quick cheat to know the reference level is if you look at the output, it'll actually be the black line. So don't know that A through Z. Great job right there, KP. And visually speaking, in R, the black line, the way Dr. Petrie coded this, the black line is actually the reference level instead of R. So no rain is first alphabetical, and so that's why it's the reference level. We're going to take a quick break. I'm going to grab a little snack, but we'll be back for some 201 here in a little bit. If you didn't get your question answered, swing back by. We're taking notes on everything. We did a lot of 320 today, so check out all that 320 in here. A lot of 320, a lot of good stuff, a lot of fun. We'll be back here next time here on Stat 201. Swing back to office hours tomorrow. I'll see everyone later. Bye.
Yeah.